A certain magnetic field has magnitude equal to 37.2 Tesla. The question is, what current will be needed to achieve such magnetic field magnitude at 2.5 centimeters from a long straight wire? Let's use the formula for the magnetic field due to a wire of current I at a distance r. It's equal to mu 0 I divided by 2 pi r. Let's rearrange our equation to isolate I. We get I equals B times 2 pi r divided by mu 0. Here r represents the distance from the wire, which is d in the picture. And then let's plug in the values to calculate the numerical result. The current needed to achieve such a magnetic field is fairly large, and it's equal to 4.65 times 10 to the 6 amps. Next, let's calculate the current needed to obtain the same magnetic field at the center of a circular coil with 120 turns and the radius equal to 44 centimeters. We use the formula for a circular coil. B equals N times mu 0 I divided by 2R. N is the number of turns, I is the current in the coil, and R is the radius of the coil. We rearrange our formula to isolate I and substitute the numerical values. We get a result of 2.17 times 10 to the 5th amps. Finally, let's calculate the current needed to obtain the same magnitude of the magnetic field at the center of a solenoid with 35,000 turns, length equal to 34 centimeters and radius equal to 2.5 centimeters. The formula for the magnetic field at the center of a solenoid is equal to N times mu 0 I divided by capital L being the length of the solenoid, N is the number of turns, I is the current in the solenoid. You may have noticed that the radius is given, but we're not using it. So why is it given? The reason why it's given is that because the length is much greater than the radius, we can use the solenoid formula in this problem. If the length and the radius were comparable, then we wouldn't be able to use the solenoid formula. For a coil to be considered a solenoid, its length should be much greater than its radius. Now, rearranging our formula, we get I equals B times L divided by N times mu 0. When we substitute the numerical values, we get a current equal to 288 amps, keeping three significant figures.